Hello students, today we will learn about operators. In the previous lesson, you have learned how to declare and initialize variables. Now you will learn how to use operators to perform arithmetic and logical operations in programming. Operators are symbols that perform arithmetic and logical operations on operands and provide a meaningful result. Operands are data values which are involved in the operation. They can be variables or constants. The operands of an operator are always evaluated from left to right. An operator needs one or more operands to perform any operation. The valid combination of both operands and operators makes an expression which returns a computed result. Let us take an example. Algebraic expression x into 4 equals to 32. Operands, operators. In the previous lesson, we have already discussed the major categories of operators. Let us discuss these operators in detail. Java operators can be classified into three categories: unary, binary, or ternary. Unary operator. These operators operate on only one operand. Example: -n, ++n, -n. The operand is n. Binary operator. These operators operate on two operand values. Example: a plus b. The operands are a and b. Ternary operator. Ternary operators operate on three operands. It is also known as conditional operator because the value returned by the expression depends upon a condition. Syntax: variable, condition, question mark, test expression 1, test expression 2. Let us take an example. C equals to bracket in A is greater than B bracket close question mark, A is to B semicolon. This means that if A is greater than B, then C is assigned the value of A, otherwise C is assigned the value of B. Before moving forward, let us first talk about arithmetic operators. Arithmetic operators are used to perform basic mathematical calculations, that is, addition, subtraction, multiplication, division, and remainder. Each of these operators are binary arithmetic operators because they require two operands to perform any calculation. An arithmetic expression may include variables, constants, and arithmetic operators to provide a meaningful result. Apart from these operators, Java provides two unary arithmetic operators that work on a single operand. These operators are further categorized as unary plus. The operator unary plus is written before the operand. This operator results in the same value of the variable. Let us understand this through an example. If A is equal to 10, then plus A means 10. If A is equal to -5, then plus A means -5. If A is equal to 0, then plus A means 0. Students note that the value without plus operator is also treated as positive value by default. The unary plus operator also performs an automatic conversion to integer data type when the type of its operand is byte, character, or short. This is called unary numeric promotion that enables you to do following things. Character C equals to single quote and C single quote close semicolon. INTI equals to plus C semicolon. Here C will be promoted to an integer before being assigned to I. Unary minus. The operator unary minus also precedes an operand. This operator inverts the value of an operand. That is, if an operand is a positive value, it converts the value of that operand to its negative value and vice versa. For example, if A is equal to 10, then minus A means minus 10. If A is equal to -5, then minus A means 5. If A is equal to 0, then minus A means 0. Okay students, let us talk about increment or decrement operators. Increment, plus plus, and decrement, minus minus operators are used to increase or decrease the value stored in a variable by 1 respectively. Using these operators, we can write the expressions x equals to x plus 1 as x plus plus and x is equal to x minus 1 as x minus minus. The increment, plus plus, and decrement, minus minus operators can be used both as prefix and as a suffix. We can use these operators in the following manner. Prefix increment plus plus x. When an increment operator precedes its operand, it is known as prefix increment. It increases the value of operand by 1 and then evaluates the expression. If y has a value of 10, x equals to plus plus y semicolon. This will store 11 in x. Y will be increased by 1 and the change value will be assigned to x. Postfix increment x plus plus. When an increment operator follows its operand, it is known as postfix increment. It evaluates the expression and then increases the value of operand by 1. If y has a value of 10, x equals to y plus plus. This will store 10 in x. The original value of y, that is 10, will be assigned to x and then y will be increased by 1. Prefix decrement minus minus x. It decreases the value of operand by 1 and then evaluates the expression. If y has a value of 10, x equals to minus minus y semicolon. This will store 9 in x. Y will be decreased by 1 and the changed value 9 will be assigned to x. Postfix decrement x minus minus. It evaluates the expression and then decreases the value of operand by 1. If y has a value of 10, x equals to y minus minus. This will store 10 in x. The original value of y, that is 10, will be assigned to x and then y will be decreased by 1. Give the output of prefix increment and decrement. 1. A equals to 9 semicolon. A equals to plus plus a slash 5 semicolon. A is increased by 1 and then divided by 5, that is a is equal to 10 by 5. Hence the final value of a is 2. 2a equals to 9 semicolon. A equals to minus minus a into 5 semicolon. A is decreased by 1 and then multiplied by 5, that is a equals to 8 into 5. Hence the final value of a is 40. Give the output of postfix increment and decrement. 1. A equals to 10 semicolon. A equals to a plus plus slash 5 semicolon. A remains 10 before division, that is a is equal to 10 divided by 5. Hence the final value of a is 2. 2. A equals to 10 semicolon. A equals to a minus minus into 5 semicolon. A remains 10 before multiplication, that is a equals to 10 into 5. Hence the final value of a will be 50. Let us understand this through an example. Create a program to demonstrate the use of unary operators. Class unary arithmetic. Curly braces in public static void main string args. Curly braces in int a equals to 20 result semicolon. Variables are declared. Result equals to plus a semicolon. System.out.println result semicolon. Result is still 20. Result equals to minus a semicolon. System.out.println result semicolon. Result is now minus 20. Result equals to plus plus a semicolon. System.out.println result semicolon. Result is now 21. Result equals to minus minus a semicolon. System.out.println result semicolon. Result is now 20. Result equals to a plus plus semicolon. System.out.println result semicolon. Result is now 20. Result equals to a minus minus semicolon. System.out.println result semicolon. Result is now 21. Curly braces close, curly braces close. Let us understand binary arithmetic operators. Operators that act upon two operands are known as binary arithmetic operators. They are defined as follows. Operator, addition, symbols, plus, format, a plus b. Description. This operator is used to add two operands. The operands can be integer, byte, short, long, etc. If they are strings, they will be concatenated. Result, if a equals to 12, b equals to 4. 16. Subtraction. minus A minus B. This operator is used to subtract the value of one operand from another. 8. Multiplication asterisk A into B. This operator is used to multiply the value of two operands. 48. Division A divided by B. This operator is used to divide the value of one operand with the value of another operand and find the quotient. 3. Modulus percentage A percentage B. This operator is used to find the remainder of a division. 0. Okay, students, know that only addition can be performed on string operands, whereas multiplication, division or modulus cannot be performed on string operands. Example 2. Create a program to demonstrate the use of arithmetic binary operators. Class arithmetic operators, curly braces in, public static void main string args, bracket close, curly braces in, int a equals to 20, b equals to 1 semicolon. Variables are declared and initialized. Integer result semicolon. Result equals to a plus b semicolon. System.out.println bracket and result bracket close semicolon. Result after addition will be displayed as 30. Result equals to a minus b semicolon. System.out.println result semicolon. After subtraction, the result will be displayed as 10. Result equals to a into b semicolon. System.out.println result semicolon. After multiplication, the result will be displayed as 200. Result equals to a divided by b semicolon. System.out.println result semicolon. After division, the result will be displayed as 2. Result equals to a percentage b semicolon. System.out.println result semicolon. After modulus, the result will be displayed as 0. Curly braces close, curly braces close. Give the output for the following statements. Number 1, number 2, number 3, number 4. Let us talk about relational operators. Relational operators are used to show the relationship between the operands. These operators compare the values of variables and determine the result in the Boolean expression format, which is either true or false. Java provides 6 types of relational operators. Operator, greater than, symbols, greater than, symbols, format, A is greater than B. Result, if A is equal to 2, B is equal to 4. True, less than, symbols, A is less than B. False, greater than or equal to, greater than or equal to, symbols, A is greater than or equal to B. True, less than or equal to, less than or equal to, symbols, A is less than equal to B. False, equal to, symbols, A equal to B. False, not equal to, symbols, A not equal to B. True. Example 3. Create a program to demonstrate the use of relational operators. Class relational operators. Curly braces in, public static void main, bracket in string args, bracket close. Curly braces in, int a equals to 16 semicolon. int b equals to 14 semicolon. System.out.println bracket in double quote and result colon if a is equal to 16 and b is equal to 14 double quote close bracket close semicolon. System.out.println bracket in double quote and a is greater than b equal to double quote close plus bracket in a is greater than b bracket close semicolon. Displays true. System.out.println bracket in double quote in a is smaller than b equals to double quote close plus bracket in a is smaller than b bracket close semicolon. Displays false. System.out.println bracket in double quote in a is greater than equal to b equal to double quote close plus bracket in a is greater than equal to b bracket close semicolon. Displays true. System.out.println bracket in double quote in A is greater than equal to B equal to double quote close plus bracket in A is smaller than equal to B bracket close semicolon displays false. System.out.println bracket in double quote in A equals to B equal to double quote close plus bracket in A is equal to B bracket close semicolon displays false. System.out.println bracket in double quote in A not equal to B equals to double quote close plus bracket in A not equal to B bracket close semicolon displays true. Curly braces close. Okay, students, note that the relational operators have a lower precedence than the arithmetic operators, but a higher precedence than the assignment operators. For example, A plus B not equal to C into C plus D into D, semicolon. Bracket in A plus B bracket close not equal to bracket in C into C bracket close plus bracket in D into D bracket close semicolon. In the above mentioned expression, A plus B and C into C plus D into D are evaluated before the relational operator not equal to is evaluated. Let us discuss about logical operators. Java uses logical operators to construct complex decision-making expressions. They provide the result in the form of true or false depending upon the evaluation of different relational expressions. Logical operators are further categorized as logical and operator. The logical and written as and is a binary operator that combines the results of two relational expressions. It returns true if both the expressions are evaluated to true, otherwise it returns false. For example, A equals to 9 semicolon B equals to 20 semicolon. A is greater than B bracket close and bracket in A is smaller than B bracket close. This will return false because one of the expressions between them is false. However, if we compare an expression, bracket in A is smaller than B bracket close and bracket in B is greater than A bracket close, the answer will be true as both the expressions are true. Let us have a look of various and expressions in the given table. Expression 5 is greater than 3 and 15 is smaller than 25. Result true. Reason both expressions are true. 15 is greater than equal to 15 and 20 is smaller than 16. False. Second expression is false. 25 is equal to 20 and 50 is greater than 30. False. First expression is false. 18 not equal to 18 and 50 equal to 60. False. Both expressions are false. Logical OR operator. The logical OR is a binary operator which also needs two relational expressions as operands. The logical OR operator returns true if either of the two conditions evaluates to true, otherwise it returns false if both conditions are false. Let us take an example. A equals to 9, B equals to 20 semicolon. B is greater than A, B is smaller than A. This will return true because first expression is true. Let us see the results of logical OR operator in the given table of various expressions. Expression 5 is greater than 8, 35 is smaller than 25. False. Both expressions are false. 28 is greater than 28, 20 is smaller than 16. True. First expression is true. 30 is equal to 20. 45 is greater than 20. True. Second expression is true. 13 is not equal to 23. 30 is equal to 30. True. Both expressions are true. Logical NOT operator. The logical NOT operator is a unary operator which deals with only one operand, relational expression. The logical NOT operator reverses the result of the expression following it. That is, if the expression returns true, then NOT operator returns false. For example, A is equal to 9, B is equal to 20, semicolon. Not equal to, A is greater than B. Let us understand the working of logical NOT operator with the given expressions in the table. Expression NOT 5 greater than 8. Result, true. Reason, 5 is greater than 8 is false. Not, bracket in 21 is greater than equal to 15, bracket close. False, bracket in 21 greater than equal to 15, bracket close is true. Okay, students, note that precedence of logical operators is not and or. That is, if a statement contains all the three logical operators and the operators are not grouped together using brackets, then not will be evaluated before any other logical operator. Example 4. Create a program to demonstrate the use of logical operators. Class logical operators. Curly braces in, public static void main, bracket in string args, bracket close. Curly braces in, int variable 1 equals to 11 semicolon. Int variable 2 equals to 12 semicolon. Character ch equals to single quote in a single quote close semicolon. System.out.println bracket in variable 1 equals to 11 bracket close and bracket in variable 2 equals to 13 bracket close semicolon. The result will be false as one of the conditions between them is false. System.out.println bracket in variable 1 is greater than variable 2 or bracket in variable 2 equal to 12 bracket close semicolon. The result will be true as one of the conditions is being satisfied. System.out.println bracket in not bracket in variable 1 is greater than variable 2 bracket close semicolon. The result will be true. Curly braces close, curly braces close. Let us learn about bitwise operators. Bitwise operators are special types of operators which perform manipulations on binary data bits. These operators are used for addition, multiplication, shifting and negating the binary data. These are also called binary operators as they are based on Boolean algebra, that is 0 or 1, where 0 indicates false and 1 indicates true. They work only with byte, short, integer and long type operands. Real and float type values do not support bitwise operators. Java provides 4 bitwise operators which are as follows. Operators and meaning, bitwise and, bitwise or, bitwise or, bitwise complement. Bitwise and. This operator returns the value 1 true if the corresponding bit in both operands is 1. Otherwise, the resulting bit is 0. The working of AND operator works similar to binary multiplication. In general, when you multiply any number with 0, then it will always result as 0. Likewise, AND operator returns 0 if one of the bit is 0. For example, A equals to 3, B equals to 5, semicolon. Binary value of A equals to 0, 0, 1, 1. Binary value of B equals to 0, 1, 0, 1. Logical AND operation is equal to 0, 0, 0, 1. Hence, decimal equivalent of result is 1. Bitwise OR. This operator returns the value 1 true if either of the two bits in both operands is 1. For example, A equals to 3, B equals to 5, semicolon. Binary value of A equals to 0, 0, 1, 1. Binary value of B equals to 0, 1, 0, 1. Logical OR operation is equal to 0, 1, 1, 1. Hence, decimal equivalent of 0, 1, 1, 1 is 7. Bitwise OR, also known as exclusive OR. This operator returns the value 1 true if the two operands bits are different. Otherwise, the result is 0. For example, A equals to 3, B equals to 5, semicolon. Binary value of A equals to 0, 0, 1, 1. Binary value of B equals to 0, 1, 0, 1. Logical XOR operation equals to 0, 1, 1, 0. Hence, A complement B is 0, 1, 1, 0 and the decimal equivalent of result is 6. Bitwise complement. This is a unary operator. The complement operator inverts the value of each bit in an operand. That is, if the operand bit is 1, the result will be 0. For example, A equals to 2 semicolon. Binary value of 2 is equal to 1 0. Bitwise complement operator equals to 0 1. Hence, bitwise complement A is 0 1 and the decimal equivalent of result is 1. Predict the output for the following codes. Number 1, A equals to 35, B equals to 46 semicolon. Hence, bracket in A and B bracket close equals to 34. Binary value of 35 is equal to 100011. Binary value of 46 is equal to 101110. Logical AND operation is equal to 100010. Decimal equivalent of the result is equal to 34. Number 2, A equals to 25, B equals to 23 semicolon. Hence, comma, bracket in A or B, bracket close is equal to 31. Binary value of 25 is equal to 11001. Binary value of 23 is equal to 10111. Logical OR operation is equal to 11111. Decimal equivalent of the result is equal to 31. Number 3. A equals to 7, B equals to 2. Hence, comma, bracket in A, bitwise complement B, bracket close is equal to 5. Binary value of 7 is equal to 00111. Binary value of 2 is equal to 00010. Logical XOR operation is equal to 00101. Decimal equivalent of the result is equal to 5. 4. A equals to 7 semicolon. Hence, comma, bracket in bitwise complement A, bracket close is equal to 8. Binary value of 7 is equal to 0111. Logical complement operation is equal to 1000. Decimal equivalent of the result is equal to 8. Example. Create a program to demonstrate the use of bitwise operators. Class bitwise operator, curly braces in, public static void main, bracket in string args, bracket close, curly braces in, int A equals to 11 semicolon, int B equals to 12 semicolon, int result semicolon, result equals to A and B semicolon, system.out.println bracket in result bracket close semicolon, result of 11 and 12 is 8. Result equals to A bitwise or B semicolon. System.out.println bracket in result bracket close semicolon. Result of 11 bitwise or 12 is 15. Result equals to A bitwise complement B semicolon. System.out.println bracket in result bracket close semicolon. Result of 11 bitwise complement 12 is 7. Result is equal to bitwise complement A semicolon. System.out.println bracket in result bracket close semicolon. Result of bitwise complement 11 is minus 12. Curly braces close, curly braces close. Alright students, let us understand shift operators. Bitwise shift operators perform bit manipulation by shifting the bits on the right and left hand side of the data. The bitwise shift operators take two operands. The first operand is a quantity to be shifted and the second operand specifies the number of bit positions by which the first operand is to be shifted. The direction of the shift operation is controlled by the operator and is used along with the operands. Java provides three shift operators as follows. Left shift. The left operand's value is moved left by the number of bits specified by the right operands. Operand smaller than number of positions to be shifted. Let us understand this through an example. 6 smaller than 1 semicolon. Number 6 is stored in memory as 0110. All the bit values shift to the left by one position and fills the empty bit on the right end with a 0 value. 0110. Shift towards left by one position. Shifting this bit pattern to the left by one position, 6 smaller than 1 would result in number 12. 1100. 12 bits are now shifted and the leftmost vacated bit is filled with 0. As you can see, the digits have shifted to the left by one position and the last digit on the right is filled with a 0. You might also note that shifting left is equivalent to multiplication of any number by powers of 2. So 6 is smaller than 1 is equivalent to 6 into 2, that is 12. Similarly, 6 is smaller than 2 will result in 24. System.out.println bracket in 6 smaller than 2 bracket close semicolon. It will display 24. Unsigned right shift. The unsigned right shift operator is just the opposite of left shift operator. Rather than moving bits to the left, it simply moves to the right. The number of bits to shift is given in the second operand. Example. Syntax operand unsigned right shift. Number of positions to be shifted. 12 unsigned right shift 1 semicolon. Number 12 is stored in memory as 1100. All the bits value shift to the right by one position and fills the empty bit on the left end with a 0 value. 1100. Shift towards right by one position. Shifting the number 12 to the right by one position, 12 unsigned right shift 1 will get back the original number 6. 0110. 6 bits are now shifted and the leftmost vacated bit is filled with 0. So you can see that shifting to the right is equivalent to division of any number with power of 2. System.out.println bracket in 12 unsigned right shift 1 bracket close semicolon. It will display 6. Similarly, bracket in 12 unsigned right shift 2 bracket close semicolon. It will display 3. The shift operator is used when you are performing logical bit operations as opposed to mathematical operations. It can be used for speed, being significantly faster than division or multiplication when dealing with operands that are powers of 2. Example. Let us understand the concept of shift operators with the following program. Class bitwise shift. Curly braces in. Public static void main bracket in string args bracket close. Curly braces in. int x equals to 4 semicolon. System.out.println bracket in x left side shift 2 bracket close semicolon. Display 16. int z is equal to 29 semicolon. System.out.println bracket in z unsigned right shift 2 bracket close semicolon. Display 7. Curly braces close. Curly braces close. Let us talk about assignment operators. Assignment operator is used to assign a value of expression to a variable. It assigns a value on its right side to the variable written to the left of it. Syntax variable equals to expression semicolon. Example. Age equals to 23 semicolon. Salary equals to 40,000 semicolon. In this example, 23 and 40,000 are the numeric values which are assigned to the variables age and salary respectively. Example. int a, b, c semicolon. A equals to 5 semicolon. B equals to 3 semicolon. C equals to a plus b semicolon. In this statement, the value of a plus b is assigned to the variable c. C equals to c into 3 semicolon. In this statement, the value stored in C is further multiplied to 3 and assigned to C. If we try to assign a new value to an operand which already contains some value, then the existing value will be replaced by the new one. A equals to 10, B equals to 20. If we write an expression A equals to B, then the value stored in A, that is 10, will be overwritten by B, that is 20. Java provides various shorthand assignment operators that simplify the coding of certain type of assignment statements. Shorthand assignment operators. Let us learn about ternary operator, conditional operator. The ternary operator (::) is also known as conditional operator. The operator needs 3 operands to perform an operation. Syntax variable equals to test expression expression 1 expression 2. Here test expression 1 is evaluated first. If it evaluates to true, then the variable contains the value of expression 1. Otherwise, it will contain the value of expression 2. In a single line of code, the Java ternary operator allows you to assign a value to a variable based on Boolean expressions. For example, int a equals to 5, comma b equals to 20, comma c semicolon. C equals to a greater than b question mark a colon b semicolon. Here the value of 20 is stored in the variable c as the test expression a is greater than b is false. Expression 6 is greater than 4 question mark 9 is to 7. Result 9. Reason 6 is greater than 4 is true. 12 smaller than 4 question mark 1 is to 0. 0. 12 is smaller than 4 is false. 2 greater than 9 question mark 4 is to 3. 3. 2 is greater than 9 false. Students, if you want to know more about operators, visit this site. Example 7. Create a program to demonstrate the use of the conditional operator. Class conditional operator. Curly braces in public static void main bracket and string args bracket close. Curly braces in int a equals to 3 semicolon, int b equals to 10 semicolon, int c semicolon. C equals to a greater than b question mark bracket in a minus b bracket close colon bracket in b minus a bracket close semicolon. If the test expression a is greater than b returns true, then the expression a minus b will be evaluated and the result will be stored in variable c. Otherwise, the expression b minus a will be evaluated and the result will be stored in the variable c. Hence, result will be 7. System.out.println bracket in c bracket close semicolon. Curly braces close, curly braces close. Rewrite the following snippet using ternary operators. Number 1. If bracket in a is greater than b bracket close, curly braces in c equals to bracket in a into b bracket close semicolon, curly braces close, else curly braces in c equals to bracket in b divided by a bracket close semicolon, curly braces close. Statement colon c equals to bracket in a is greater than b bracket close question mark bracket in a into b bracket close colon bracket in b divided by a bracket close semicolon. Number 2. If bracket in marks are greater than equal to 89 divided by 100 bracket close, marks greater than equal to 89%, curly braces in grade equals to A1 semicolon, curly braces close, else curly braces in grade equals to B1 semicolon, curly braces close. Statement colon grade equals to bracket in marks greater than equal to 89 by 100 bracket close question mark bracket in A1 bracket close colon bracket in B1 bracket close semicolon. Number 3. If bracket in salary is greater than equal to 20,000 bracket close, curly braces in bonus equals to bracket in salary into 5 bracket close divided by 100 semicolon bonus 5%, curly braces close, else curly braces in bonus equals to bracket in salary into 2 bracket close slash 100 semicolon bonus 2%, curly braces close. Statement colon bonus equals to bracket in salary greater than equal to 20,000 bracket close question mark bracket in salary into 5 bracket close slash 100 colon bracket in salary into 2 bracket close slash 100 semicolon. Let me tell you about special operators. We will now see some special operators that the Java programming language supports. Type operator. This operator converts a value in a variable into a specified data type. You will learn the use of type operator later in the lesson while reading about the concept of typecasting. New operator. This operator is used to create a new object. For example, fruit apple equals to new fruit parenthesis semicolon. Instance of operator. This operator is also called as an object reference. It is used to check whether the object belongs to a particular class. It returns the value true if its first operand is an instance of its second operand. Example. Let us take the example of fruit class to demonstrate the use of instance of operator. Public class fruit, curly braces in, public static void main bracket in string args bracket close, curly braces in, fruit apple equals to new fruit parenthesis semicolon. Boolean result equals to apple instance of fruit, semicolon. System.out.println, bracket and result, bracket close, semicolon. Curly braces close, curly braces close. This would produce the result true because the object apple belongs to the class fruit. The operator. While declaring a method or calling a method, the parameters of the method are passed between parenthesis operator. One can also pass an empty argument. Alright students, let us understand precedence of operators. Operators in Java work much like they do in mathematics, producing a value from one or more operands. Operator precedence are rules that determine the order of operations when operators of equal precedence appear within the same expression. The easiest way to remember the order of precedence rule with respect to the basic arithmetic operators is to think of the mnemonic commonly used in mathematics, that is BODMAS, which provides that operations proceed in the following order: bracket, of, division, multiplication, addition, subtraction. Precedence, lower precedence, higher precedence, operator, type, parenthesis, array subscript, member selection, associativity, left to right, unary post increment, unary post decrement, right to left, unary pre-increment, unary pre-decrement, unary plus, unary minus, unary logical negation, unary bitwise complement, unary typecast, right to left. Multiplication, division, modulus, addition, left to right. Subtraction, bitwise left shift, left to right. Bitwise right shift with sign extension. Bitwise right shift with 0 extension. Relational less than. Relational less than or equal, left to right. Relational greater than. Relational greater than or equal. Type comparison object only. Relational is equal to, left to right. Relational is not equal to, left to right. Bitwise and, left to right. Bitwise exclusive or, left to right. Bitwise inclusive or, left to right. Logical and, left to right. Logical or, left to right. Ternary conditional, right to left. Assignment, addition assignment, subtraction assignment, multiplication assignment, division assignment, modulus assignment, right to left. Students, note the fact file. If the operators of the same precedence appear in an expression, then the leftmost among them will be evaluated first. Let us learn about expressions. An expression is composed of one or more operands and returns a value as a result. It may consist of constants, variables, functions, return values and operators. An expression can be mathematical, relational or logical, or it could be a compound expression depending upon the result it produces. Time for fact file. Expression are combinations of operators and operands used to perform a calculation. Arithmetic expression. An arithmetic expression may include variables, constants and arithmetic operators to provide a meaningful result. For example, average equals to total marks divided by number of subjects, semicolon. The above mentioned expression is an arithmetic expression. It will store the result of the division into the variable average. An arithmetic expression is further categorized into pure arithmetic expressions and mixed arithmetic expressions. Pure arithmetic expressions, an expression that has all operands of same data types. These expressions can be pure integer expressions or pure real expressions. Example: pure integer expression will contain only integer values. If a and b are two integer variables, then the following are pure arithmetic integer expressions. Number 1, b equals to bracket in a into 5 bracket close. Number 2, a equals to a into plus b. Number 3, b minus bracket in a into 2 bracket close. An expression that contains only real constants and or real variables using arithmetic operators is known as real arithmetic expression. If m and n are two floating variables, then number 1, m divided by n. Number 2, m into n minus 2.67. Number 3, m plus bracket in n into 1.4 bracket close will be considered as real arithmetic expressions. Mixed arithmetic expression. If an expression contains both integer and real values, then it is known as mixed arithmetic expression. Example: float pi equals to 3.14 semicolon. int radius equals to 3 semicolon. Double area of circle equals to pi into radius semicolon. Boolean expression. Evaluations of expressions that result into true or false are called Boolean expressions. Boolean expressions are valid combinations of constants, variables, relational and logical operators. Number 1, int a equals to 20, int b equals to 10 semicolon. Boolean c equals to a is greater than b question mark true colon false semicolon. Number 2, score equals to 100 semicolon. String a equals to bracket in score equal to 100 bracket close question mark double quote in excellent double quote close colon double quote in good double quote close semicolon. Alright, let us talk about statements. A Java program is a collection of statements and expressions. Statements direct the computer to perform an action. They can alter the value of variables, process input, generate output, or respond to user mouse or keyboard actions. Statements form the smallest executable unit and are always terminated with a semicolon. Java statements are categorized as follows. Expression statements. Expression statements are valid Java expressions that are terminated by a semicolon. Expression statements are defined as follows. A equals to 1 semicolon. Assignment. X into equals to 2 semicolon. Assignment with operation. I plus plus semicolon I minus minus. Post increment, post decrement. Minus minus C semicolon plus plus C semicolon. Pre-decrement, pre-increment. System.out.println bracket in double quote in statement double quote close bracket close semicolon. Method invocation. Fruit apple equals to new bracket in fruit bracket close semicolon. Object creation. Students, let us know more. There is no delete operator for releasing memory in Java like C++ due to automatic garbage collection process. Assignment statements. The assignment statement is used to assign a value to a variable on the left side of the equal sign, with the value of expression given on the right-hand side of equal sign. For example, int a equals to bracket in b into c bracket close divided by 4 semicolon. In addition to these, Java provides two more statements named as declaration statement, control statements. Declaration statement. This statement is used to declare a variable. As we have seen that every variable is declared before it is used in a program. For example, int a, b, c, semicolon. Control statements. These statements are used to control the flow of program. Example, if else, for, while, break, etc. You will learn more about the control statements in the forthcoming chapter. Null statement. The null statement in Java is written as a single semicolon. The empty statement does not do anything, but this syntax is occasionally useful. It can be used to indicate an empty loop. Let us understand this through an example. For bracket in int a equals to 0 semicolon, a is smaller than 10 semicolon, a plus plus bracket close. Curly braces in, semicolon, loop body is empty, curly braces close. Compound statement. A sequence of statements grouped together within a pair of curly braces is called compound statement. Example. For bracket in int a equals to 0 semicolon, a is smaller than 10 semicolon, bracket close. Curly braces in, if bracket in a greater than 10 bracket close. curly braces in, system.out.println, bracket and double quote and stop here, double quote close, bracket close. Body of this loop is a compound statement as it consists of two expression statements within curly braces. A plus plus semicolon, curly braces close, curly braces close. Block statement. A block is a group of 0 or more statements between the braces and can be used anywhere in the program. Example. The following example illustrates the use of block statement. Public class block, curly braces in, public static void main, bracket and string args, bracket close, curly braces in, boolean condition equals to true, semicolon. If bracket and condition, bracket close, curly braces in, begin block 1. System.out.println, bracket and double quote and condition is true, full stop, double quote close, bracket close, semicolon. Curly braces close, end block 1. Else, curly braces in, begin block 2. System.out.println, bracket and double quote and condition is false, full stop, double quote close, bracket close, semicolon. Curly braces close, end block 2. Curly braces close, curly braces close. Students, let us understand how to understand about accepting arguments through the main method. Arguments are the values that are assigned to a method or function as input parameters. The process of assigning values to a method is called passing arguments. The output of the method or function is based upon these inputs. While executing a program through its main method, we can design the program to accept some arguments from the user. This can be achieved if we pass a variable as an argument to the main method. Example. Write a program to swap two numbers without using third variable. Public class swapping. Curly braces in, public static void main, bracket in int a int b, bracket close. Curly braces in, system.out.println, bracket in, double quote in, entered values are double quote close plus a plus double quote in and double quote close plus b, bracket close, semicolon. A equals to a plus b, semicolon. B equals to a minus b, semicolon. A equals to a minus b, semicolon. System.out.println, bracket in, double quote in, value of a is double quote close plus a, bracket close, semicolon. System.out.println, bracket in, double quote in, value of b is double quote close plus b, bracket close, semicolon. Curly braces close, curly braces close. Example. Create a program that will accept the amount in odd and convert it into rupees. Bracket in, assume that $1 equals to rupees 56.50. Bracket close. Public class currency. Curly braces in, public static void main, bracket in int au underscore doll, bracket close. Curly braces in, double in underscore rupee, semicolon. In underscore rupees equals to au underscore doll into 56.50, semicolon. System.out.println, bracket in, double quote in, odd double quote close plus au underscore doll plus double quote in equals to rupees double quote close plus in underscore rupee plus double quote in, bracket in, at odd 1 equals to rupees 56.50, bracket close, double quote close, bracket close, semicolon. Curly braces close, curly braces close. Students, let us take a quick quiz. Which delimiter is used to represent the string literal in a program? Let me tell you about math class. Math class is a very important class in Java. Math class has many functions that help us in solving mathematical problems. Let us understand the important methods of math class. Squared. Argument double. Return type double. This function accepts a double value as an argument and returns its square root. POW, argument, two double values. Return type, double. This function returns x raised to y. It accepts two double values as arguments. The first argument is considered as the base and the second argument works like the index to indicate the power value. Students, let us know more. All methods of the math class are static, meaning they are invoked through the class name. Random, argument, nil, return type, double. This function is used to get a random real value between 0 and 1. It does not accept any argument. Whenever this function is called, it returns a real value between 0 and 1, such as 0.33, 0.78, 0.1, etc. Max, argument, two double values. This function can also work within integer, long and float arguments. Return type, double. This function accepts two double, integer, long, float values and compares them to find the greater one. It returns the greater value among the two. Minimum, argument, double value. This function can also work with integer, long and float arguments. Return type, double. This function accepts two double, integer, long, float values and compares them to find the smaller one. It returns the smaller value among the two. ABS, argument, double value. Return type, double. This function accepts one double value as argument and returns its absolute value. If the number is positive, it is returned as it is. If it is negative, then the positive number is returned. R integer, argument, double value. Return type, integer. This function accepts a double value and returns the integer value that is closest to it. Sin, argument, double value. Return type, double. This function accepts a double value that represents an angle in radians. It returns the sine value of the past argument. Cell, argument, double value. Return type, double. This function accepts a double value and returns the integer value that falls after it. It returns the result in double format. Floor, argument, double value. Return type, double. This function accepts a double value and returns the integer value that falls before it. It returns the integer in double format. Cos, argument, double value. Return type, double. This function accepts a double value that represents an angle in radians. It returns the cosine value of the past argument. Tan, argument, double value. Return type, double. This function accepts a double value that represents an angle in radians. It returns the tangent value of the past argument. Log parenthesis, argument, double value. Return type, double. This function accepts a double value as argument and returns its natural logarithmic value. EXP, argument, double value. Return type, double. This method accepts the double value as argument and returns the value e, where e is the base of the natural logarithms. Some other functions of math class are listed in the following table. Functions: a sine, bracket in y, bracket close, action. This function returns the angle whose sign is y. Example: math.asine, bracket in 6, bracket close, a cos, bracket in y, bracket close. This function returns the angle whose cosine is y. Mat.acos bracket in 6 bracket close, a tan bracket in y bracket close. This function returns the angle whose tangent is y. Mat.a10 bracket in 6 bracket close, a tan 2 bracket in x comma y bracket close. This function returns the angle whose tangent is x or y. Mat.a10 bracket in 2 3 bracket close. Round bracket in x bracket close returns the rounded value up to the nearest integer. Mat.round bracket in 5 bracket close. Let us learn about errors in Java program. Errors are mistakes that affect the functioning of a program. Every program or application is designed to solve a real-life problem. But if the program contains errors, it can lead to wrong results or sometimes no results at all. At times, we confuse ourselves between errors and bugs. A bug is a flaw in a program due to which something works incorrectly. On the other hand, an error is flaw or mistake where the program might not work at all. However, these definitions are quite fluid and depend mostly on the context. The process of removing bugs is called debugging. Programming errors can be divided into three major categories. Syntax errors. Syntax errors prevent the program from getting compiled. These errors are caused due to mistakes that you make while typing the code. Some mistakes can be wrongly written keywords, forgetting necessary punctuation, writing incomplete statements, etc. At the time of compilation, the compiler converts the programming statements into machine-level code. During this process, if the compiler finds a piece of code that it does not understand, it generates an error. Therefore, in simple language, you can say that the errors caused due to the incorrect programming statements are known as syntax errors. Some common syntax errors are missing semicolon, missing braces, wrong punctuation, use of those variables which have not been declared in the program, misspelled keywords, using a variable without assigning any value to it. Let us understand this through an example. Logical errors. Before writing a piece of code, a good programmer always designs a programming logic in his mind. If the design logic is incorrect, it may lead to wrong output. Such errors are called logical errors. The programs with logical errors may get compiled and executed, but such programs may not give the desired output. Some common logical errors are use of a wrong or incorrect formula, an error in algorithm, or even the wrong selection of an algorithm. Let us understand key concept. Logical operators can be used to construct sophisticated conditions. For example, speed equals to distance divided by time, bracket in correct logic, bracket close. Speed equals to time divided by distance, incorrect logic applied. Result an unexpected output. Hence, logical error is the result of an incorrect logic applied by the programmer. Runtime errors. Java runtime errors are those errors that occur during the execution of a program due to some illegal operations performed in the program. Examples of some illegal operations that may produce runtime errors are dividing a number by 0, trying to open a file which is not created, insufficient memory. Alright students, let me tell you about data type conversion. Data type conversion is the process of changing one data type into another. The most important feature of data type conversion is to prevent data loss while dealing with expressions containing multiple data types. Example: suppose you have a jar filled with juice and an empty glass. If you want to shift the juice from a jar, either you have to take a jar of the same size or some bigger vessel. But if you try to shift the juice in a glass, you will lose some amount due to the smaller size of the glass. Likewise, while doing data conversion, you cannot pour an integer full of stuff into a bite-sized container because this way data will be lost. You want to evaluate an expression having operands of different data types. Data type conversion helps us to convert all data into a single data type and then evaluate the expression. Let us take an example. If I equals to 8.0 and j equals to 5.0, then the result is 1.6. This is how the data is lost if we do not choose the correct data type. Luckily, in Java, we can easily convert the data type depending upon our requirement. The data type conversion can be done in two ways: implicit type conversion, explicit type conversion, typecasting. Okay students, let us know more. Automatic type conversion is also known as widening casting. Implicit type conversion. In implicit type conversion, data types of various operands are automatically converted by the compiler. Implicit type conversion converts data types of all the operands to the largest data type present in the expression. Let us sort the various data types in an ascending order depending on the amount of memory needed. In an expression contains values of different data types, then the results of each operation are evaluated in such a way that the data type of the result is of the higher data type, higher of the two. Let us understand the concept of implicit type conversion with the help of the following expression. Example: int I equals to 12 semicolon, float f equals to 3.9 f semicolon, double d equals to 4.2 comma dg semicolon, long L equals to 3 semicolon, dg equals to d plus f minus I divided by L semicolon. In the above mentioned statement, expression I divided by L will be evaluated first, that is, an integer is going to be divided by a long. The result will be a long 4. The second expression could be d plus f. A double 4.2 is being added to a float 3.9 and the result will be a double 8.1. Finally, the long 4 will be subtracted from the double 8.1 and it will result in the double 4.1. So the final result, double 4.1, will be stored in the double variable dg. Example: let us understand the automatic conversion with the help of a simple program. Public class automatic casting, curly braces in, public static void main, bracket in string args bracket close, curly braces in, int a equals to 50 semicolon, long b equals to a semicolon, no explicit type casting required, double c equals to b semicolon, no explicit type casting required. System.out.println bracket in double quote in integer value is double quote close plus a bracket close semicolon. System.out.println bracket in double quote in long value is double quote close plus b bracket close semicolon. System.out.println bracket in double quote in double value is double quote close plus c bracket close semicolon, curly braces close, curly braces close. Output. Let us know more. The automatic conversion of one data type into another data type is sometimes known as conversion. Explicit type conversion, typecasting. The automatic type conversions are helpful, but they do not fulfill the user requirements completely. For example, if you want to assign an integer value to a byte variable, the conversion will not be performed automatically because the byte data type is smaller in size than integer. Such kinds of conversions are done forcefully by a programmer and are called explicit type conversions or typecasting. Syntax: variable 1 equals to new data type, variable 2 semicolon. Example: float a semicolon, int b semicolon, b equals to bracket in int bracket close a semicolon. In the above mentioned statements, you want to assign the value stored in variable a to the variable b. B is an integer type variable while a is a float type variable. Hence, you are forcibly trying to convert the data type of the variable a from float to integer. You already know that integers do not have fractional components. Thus, when we assign a float type value to an integer type variable, the fractional component is lost. Alright students, let us know more. Explicit type conversion is also known as narrowing conversion. Example: integer a equals to 10, b equals to 3, semicolon, float c semicolon, c equals to a divided by b semicolon. The problem can be resolved by explicitly converting the variable a or b or both. C equals to bracket in float bracket close a divided by b semicolon. This will result in 3.333 which will be stored in C. Since such kinds of conversions are forcefully done by the programmer, so he is fully aware of the changes in the output of a program. Although in the above mentioned program you observe a loss of data, fractional component, yet sometimes you are willing to perform such operations. Time for fact file. Java follows a well-defined set of precedence rules that governs the order in which operators will be evaluated in an expression. For example, to understand the need of explicit conversions in real-life scenarios, let us take an example of a billing machine at a grocery shop. Create a billing program which may return a fractional value after adding taxes and deducting applicable discounts. Suppose the bill amount is Rs 546.78. For this bill, a user can pay Rs 546, considering that the payment of 78 paise is an unfeasible job. You want that the program should display the payable amount as a whole number, that is rupees 546 only. Hence, to convert the fractional value into an integer value, you will explicitly convert the float type data to the integer type data. The same can also be obtained by using C, flow or int methods of the math class. Example. Let us understand the concept of explicit type conversion using the following example. Public class explicit casting, curly braces in, public static void main, bracket in string args, bracket close, curly braces in, double A equals to 50.25 semicolon, long B equals to long A semicolon, explicit type casting required, integer I equals to integer B semicolon, explicit type casting required. System.out.println bracket in double quote and double value is double quote close plus A bracket close semicolon. System.out.println bracket in double quote and long value is double quote close plus B bracket close semicolon. System.out.println bracket in double quote and integer value is double quote close plus B bracket close semicolon. Curly braces close, curly braces close. Output. Example. Create a program that will accept the distance covered by a cab and calculate the total bill. The 1 kilometer will be charged at rupees 20 and each consequent kilometer will be charged at rupees 17.50 per kilometer. Public class cab, curly braces in, public static void main, bracket in float distance, bracket close, curly braces in, integer amount semicolon. Amount equals to bracket in int bracket close bracket in 20 plus bracket in 17.5 into bracket in distance minus 1 bracket close semicolon. System.out.println bracket in double quote and distance traveled equals to double quote close plus distance plus double quote in kilometers full stop double quote close bracket close semicolon. System.out.println bracket in double quote in please pay rupees double quote close plus amount plus double quote in division minus double quote close bracket close semicolon. System.out.print bracket in double quote in thanks for choosing Himachal Cab Services full stop double quote close bracket close semicolon. System.out.println bracket in double quote in for further cab queries please call 011-8888 9999 double quote close bracket close semicolon. Curly braces close, curly braces close. Output. Alright, let us discuss about getting input from keyboard. It is often useful to design a program to input data from the user interactively during execution. In this manner, new results can be computed each time the program is run, depending on the data that is entered. To input data from the user, Java provides scanner class, which is a standard Java class library, java.util.scanner. It provides convenient methods for reading input values of various types. To use scanner class, write the following import statement at the top of your program. Import java.util_scanner semicolon. Next, in your program code, create an object of the scanner class. Scanner sc equals to new scanner bracket in system.in bracket close semicolon. This declaration creates a variable by using a new operator that represents a scanner object. You can use any name for the object as desired. The scanner accepts a parameter that indicates the source of the input. The system.in object represents the standard input stream. Use the following next methods to get the inputs of various data types as given in the list. String next, parenthesis. To input a word, stops input when space is encountered. String next line, parenthesis. To input a line of character string, that is a sentence. Stops input when enter key is pressed. Boolean next boolean, parenthesis. To input a boolean value, byte next byte, parenthesis. To input a byte value, double next double, parenthesis. To input a double, float next float, parenthesis. To input a float value, int next int, parenthesis. To input an integer, integer value. Long next long, parenthesis, to input a long integer long value. Short next short, parenthesis, to input a short integer short value. Example, to input an integer, system.out.println bracket in double quote and enter an integer value colon double quote close bracket close semicolon. INTN equals to sc.next int parenthesis semicolon. To input a double, system.out.println bracket in double quote and enter a double value colon double quote close bracket close semicolon. Double D equals to sc.next double parenthesis semicolon. To input a string, system.out.println bracket in double quote and enter a single word colon double quote close bracket close semicolon. String word equals to sc.next parenthesis semicolon. System.out.println bracket in double quote and enter a sentence colon double quote close bracket close semicolon. String line equals to sc.next line parenthesis semicolon. Let us understand system.out.print statement. To get the output on the screen, we use system.out.print bracket in double quote in any text double quote close or variable bracket close semicolon, or system.out.println bracket in double quote in any text double quote close or variable bracket close semicolon. System.out represents monitor screen and print or println is the method that prints the given text on the screen. The difference between print and println is small but important. The println method prints the information sent to it, then moves the cursor to the beginning of the next line. The print method is similar to println but does not advance to the next line when completed. Example, write a program to print the different character on the terminal window using different printing statements. Public class character demo. Curly braces in, public static void main bracket in string as bracket close, curly braces in. Character ch1, ch2 semicolon. Character 1 equals to 75 semicolon, quote for k. Character 2 equals to single quote in L single quote close semicolon. System.out.print bracket in double quote in character 1 and character 2 colon double quote close bracket close semicolon. System.out.println bracket in character 1 plus double quote in double quote close plus character 2 bracket close semicolon, curly braces close, curly braces close. Output. Okay students, let us now do some programming practice. Example, a computer manufacturing company announces a special offer to their customers on purchasing laptops and their printers accordingly. On laptop, discount is 12%. On printer, discount is 10%. On both, discount is 15%. Example, write a program in Java to calculate the discount if a customer purchases a laptop or a printer or both. Public class discount, curly braces in, public static void main bracket in integer lap underscore amount 1, comma integer price underscore amount 1, bracket close, curly braces in, integer r1 equals to 12, comma r2 equals to 10, comma r3 equals to 15, semicolon. Double a1, comma a2, comma m equals to 0, comma n equals to 0, semicolon. A1 equals to double R1 divided by 100 into lap underscore amount 1 semicolon. A2 equals to bracket in double bracket close R2 divided by 100 into price underscore amount 1 semicolon. Lap underscore amount 1 equals to lap underscore amount 1 minus bracket in integer bracket close A1 semicolon. PR underscore amount 1 equals to PR underscore amount 1 minus bracket in integer bracket close A2 semicolon. System.out.println bracket in double quote in the price of laptop after discount if only a laptop is bought is equal to double quote close plus lap underscore amount 1 bracket close semicolon. System.out.println bracket in double quote in the price of the printer after discount if only a printer is bought is equal to double quote close plus PR underscore amount 1 bracket close semicolon. A1 equals to bracket in double bracket close R3 divided by 100 into lap underscore amount 1 semicolon. A2 equals to bracket in double bracket close R3 divided by 100 into PR underscore amount 1 semicolon int lap underscore amount 2 equals to lap underscore amount 1 minus bracket in integer bracket close A1 semicolon int PR underscore amount 2 equals to PR underscore amount 1 minus bracket in int bracket close A2 semicolon system.out.println bracket in double quote in the price of laptop after discount if both laptop and printer are bought is equal to double quote close plus lap underscore amount 2 bracket close semicolon system.out.println bracket in double quote in the price of printer after discount if both printer and laptop are bought is equal to double quote close plus price underscore amount 2 bracket close semicolon curly braces close curly braces close. Output example